All right. So going through the basic Python programming, we have variables, this guy here, and then we have values. Values are basically what we store in variables. Just like when you're looking at your cupboard, that's you can imagine it as a space where the computer keeps values that you put in, and that's how it works. So we'll just use the first one to illustrate. So we have number one as 93, number two as 25. So when I run this code, you can see that when we add number one and number two, it gives us 1 and 8. All right, let me put this down out and then let me. Okay, it doesn't give anything because we comment it. That's one way we comment it. So let's see what the computer store as number one, 93. That's what it gave us here. And let me uncomment it. Uh, so it stores the number two as 25. If you notice, you'll see that it completely ignores number one, right? So let's comment number two out there and let's see. So that's how it works. And it completely ignored the answer that we gave here. So let's uh, comment it. And yeah, it doesn't give us anything. So it gives us the number. So when we want to do multiplication, we use this sign here, this little sign here. And when we run it, we have 23, 24. So that's what we have there. And we want to divide it, we get 3.72 as a float. And when we want to convert it to the nearest integer, we use a double slash here. Then when we want to print a message, uh, we use this. But there's a very cool way of doing it. Mm, this is a cool way of writing. And let's say want to store someone's name as Billy. Okay, right. Hello, hello. Sorry, hello, hello, Daily. So, mhm. So we should be able to get something different or an error. It's bringing an error. What is it saying? Invalid syntax. All right. So that's F string for you. I used the wrong syntax for this question. So let's try it again. All right. Nice. So it printed both the first message and the second message. Isn't that cool? And look at it. Hello, Delhi. And I think this is a very good way of writing your Python stuff. I can imagine we can do something. We can do something. Let's do something. We can ask for a user's name, then greet the user, and that's what we'll do later in the chapter. So moving on, we have uh, an escape number. This just means an extra line. And when we run this, it shows us first line and then the second line. Then if we want to get two digits, you can say the answer is 3. Now, this answer goes to the last computed value, which is 3. That's why it gives us 3. So if I run this particular one and I come here to run this particular one, it saves it as a new value. So you see 3.72 as the new value. So moving on, here we can call for a user to enter a text, and then we can, let's say, let's use the F strings. to uh, uh, okay, the value you sorry you entered is text, yeah, text value. So ask the we ask the user to enter a text value, and then we oh boy, all right, let's see, let's say it's for 34, and what does it tell us? So look at what it said. The value you entered is 34. Isn't that cool? So instead of using print, you can use an f string, and then voila, it performs the same thing, and it allows you to place all the right uh, stuff in it. Now, the beauty of this comes in when you are trying to mail 5,000 people, and you want to personalize the mail for each person. That's where you get the value of this, and it makes your work very beautiful. So we can move straight to the next one called okay, the answer is 3.72. So it picks the last one. So here we have two digits, just like the first one. So we call it X and Y, but X and Y is greatly discouraged in programming. Why? Because we call them magic numbers. We call them X is unknown, Y is unknown. So most very, because we don't write programs beyond writing programs for the computer to run. We actually write programs so that the next person that may handle it, maybe you leave the company, so another one will have no issues locating what the variable x or what the variable y means. So this is greatly discouraged while you're programming. So then this one talks about casting. We pick the input from the user, any input from the user, and then we cast it to an int. Now we told the user to enter a number. That's the instruction. Now, if a user enters something that is completely different, we can have an error. So let's run it and demonstrate that fact. Because okay, let's say I don't want to put a number. I want to be disobedient user. So look at what it's giving me. First, this is what it says: value error. Why? Because it's expecting an int. So since it doesn't see an int, it quickly tells me, oh, you have an error in line 1. This is the number. This is the equation you gave me. The value invalid literal for int with base 10. So it's telling me, sorry, I can't find any number that has this value as jg. Well, all right, good. So sorry, computer, I'll give you what you want. So let me give him a number. So I gave him that number. I want to be mischievous here. So let me put a decimal and then put another number. So let's see. Oh, it's crying. Look at what it said. Value error. Most recent call last. Then it tells me input enter a number. Okay, this is what it says. Uh invalid literal for int with base 10. So it can't find a number that has a decimal with base 10. So it's telling you that, oh, this number you gave me is not an integer, it's a float. It's another of the types that we have in Python. So that's why it's giving that error. So I'm gonna try it the last time, but this time I'm gonna be a good boy. All right. So let's see. 34. Good. So it completely accepted the instruction. So the code runs perfectly. So y- yet quickly talks about loops. Now this is what you be do daily. uh, it talks about flows, controls. Example, it starts here, then it meets. a junction where it asks a question. The number I get, is it greater than 10? If it is yes, all right, good. This is over. The number is 10. This is over 10. So it's telling you the number is over 10. Okay. If the number is not greater than 10, so it tells you, let me move to the next decision. Is this number equal to 10? If it is no, it ignores it and moves straight. It says this is under 10, and then it moves on. But if it's a yes, it tells you, oh, this number is equal to 10, and then it starts. And this is what is represented here as this variable that is given is contrasted against this one. If it is greater, this actually means greater than. So we print. We can actually use f strings here rather than using print. I think it will work. Thinking? Nah, it will work. But it might just confuse the next developer. We can just replace this with f strings and it should work. All right, my pieces doing over Sabi Housewife. All right, so it picks the last number, that is number one. I want to be mischievous here, so I'm going to change it to number 23. It's already complaining that, hey, you didn't tell me anything about number 23. So, okay, let me be a good boy. All right, so number two is already telling me, hey, number two is 25. So let's try it. Immediately I send it. Nothing is printed out. Are you kidding me? Let's try it again. Okay. The reason why nothing is printed out is because though I made this a string, which is beautiful, I did not use the return value. So if I use the return value, let's see whether it's gonna work. Fingers crossed, people. Fingers crossed. So let's see. Will it work? Will it give me an error? So this is what it said. Return is outside. Oh, see, is it? All right. All right. So look at what it said. Return can only be used within a function. Hmm. All right. So this is the part I'm gonna cut out. Okay. So we have this. So f string here didn't work. All right. Let's see if we can cover f string with the print function. Oh, sorry. Say print. Exploring this together, guys. So we say print here. And then the last one, print. So let's see. Will it work? We give an error. So let's see. Why is it giving us this is 10? So it actually works with the other one. So but f is greater than 10. Okay, this is why it's saying this is 10. But actually what we should have written is this is greater than 10, and we can make it very cool. This is where we actually have fun. We can say number 2 is greater than 10. Sorry, he's already complaining. Guy, you didn't tell me that I have you made 2. So we can put it like this and then use it to replace it. So it immediately tells us the number, and this is cool. This makes programming much beautiful. So let's see. Look at what it's telling us. 25 is greater than 10. Awesome, right? So that's it. I want to be mischievous here. Yeah, I just let me put it here. All right, good. So I'm gonna call um number two here. Excuse me. I'm gonna call number two. Yeah, I'm gonna call it. Let's say three. I want to see what happens. So it says three is it's number 10. No, no, we just say less than. Let's say less than 10. So what the condition is, if 2 is greater than 10, we say if the value is greater than 10, we say oh it's greater than 10. If it is equal to 10, we say it's equal to 10. And if it is, or we just say it's less than 10. So let's run it again. Look at what it says. Oh, it's less than 10. So let us make it 10 this time. All right, so we're storing it and then running it. Let's see. Is less than 10? No, this is wrong. What is happening? But look at our code. Our code was wrong. Did you see? So it's comparing number one. So uh we'll not do that. So let's try it again. Good. 10 is equal to 10. So it's always right when the programmer uses the right function. So thank you for listening.